This is Chintan Patel and welcome back to the video lecture series of the fundamentals of machine design. In this lecture, we are going to learn about the design against the static loads. So, this is the first chapter. You can consider it in the basics of the designs. After that, you will learn about the advanced designing and the different softwares regarding the designs. But all of these concepts are going to be have the base at these chapters, and these are the very important chapters that we are going to learn today. So let's get started with the first slide, in which we will see a theoretical part which covers what is machine design. Now, what is machine design first of all? In the examination, you may be asked about the machine design definition as well as what kind of a machine design or what are the types of the machine design in the market or in the current scenario. So let me give a brief idea about the machine design definition. So first of all, if you see on this diagram, then you will see that the machine is a combination of several machine elements arranged to work together as a whole to accomplish a specific purpose. So our machine is a part or a combination of components which serves a specific purpose, or we are intended to serve a specific purpose, or our intention is to fulfill a specific purpose, whether it is a manufacturing or any luxury or anything that can be fulfilled by a combination of the machine component is known as a machine. Okay, so the machine design involves the designing the elements and arranging them optimally to obtain the some useful work. So our design is the procedure which combines all those components and arrange them so that you can get your desired work output as per the requirement with optimum output, okay, with optimum efficiency. So the machine design is the process of engineering design. A machine is made up of the mechanism that work together to satisfy the requirement of what the machine needs to accomplish. So our main purpose and the main target is to fulfill the function that we need to need a machine to be doing. Okay, so first of all, we need to identify that purpose and a function that we need to accomplish using the by the aids of the machines. So this was the basic definition that why we need a machine design in our mechanical syllabus, as well as what is the machine design. So now we will see another theoretical portion which can be asked in a short theory, 2 to 3 marks. What are the types of the machine design? The types of the machine designs are basically 3. The first one is the adaptive design, second one is the development design, and the third one is the new design. Now there is a very vast difference between those types. As you can see, the first name itself indicates that the adaptive design is the design in which the designer just adapt the ready-made machine components or any parts that are readily available in the market or in the world. So they have not, the designer has not utilized his skills or any efforts to create the new design. The adaptive design may have some changes, but those are the changes which are minor changes, and most of the design parts, most of the design features are the same from the adapted design. Okay, so this type of a design requires a very less skill set and less knowledge of the machine design. Any person with a basic knowledge of the machine design can do this kind of a design. So that this is the basic design which is nowadays adapted in many countries and in many industries. Now we will see the second type of a design, that is the development design. Now the name contains the word development, and this development is done from the one which is already available. Okay, so marks my words, that we as a designer, if we are choosing the development design, then what we are our intention is to adapt first a ready-made available design. Then we will develop our design according to requirement. So we will develop and provide the modification into that design, and according to that modification, the final design will be a lot more different from the basic design. Okay, so our final design will be a lot more different, and it will be hard. It will be hard enough for anyone to differentiate between the to find the similarities on those two designs. The first one which we have adapted, and the second one which we have developed from the adapted design. So this development process contains the identification of the functions that you need to accomplish using that particular component. So this development is based on the requirement, and for this particular development, a designer need a moderate amount of a skill set to modify the adapted design into a new particular functional design. So there are a lot of types, lot of designs which are carried out nowadays in the industries, where a particular industry may have made that component in their own domain, but different industries modify that component according to their working environment, and to fit it into the working environment, they create the new design from the adapted design. So this is not something like that you are creating the whole new design, but this is the design which is done or modified or developed from a design which is already available in the market. Okay, so this is the basic idea of the development design. Now we will see the last design, that is the new design. Now the word itself indicates that this is the completely new design, and anything in the world does not exist like this. If you are creating something like new, that if you are creating a time machine for the first time, and which is not available in the world right now, and if you are the first one to create that machine into the and introduce to the people of the world, then that particular design will be considered as a new design. And the new designs can be patented, and anything will be done with the anything can be done as a owner of that design. Now this design is completely new, and that's why a designer need a lot more highly qualified skill sets to create this kind of a design. And the quest of the ideas should be there in the mind of creative ideas should be there in the mind of a designer, so that they can find the different solution for the different problems of to create the particular new design. So these are the types of the design. Now we will see another theoretical portion of this chapter, and that is nothing but the general procedure in the machine design. So what are the procedure, or what are the steps that are used in the machine design? And these are basically the 8 number of steps which can be asked in your examination into the 5 to 7 marks. And if they are asked in the 7 marks, then you need to elaborate each and every steps so that you can get the full marks up to 7. Okay, so now we will start with the first one. The design procedure starts from the moment that you think about the design. Okay, so whenever you are thinking an idea about any machine or any component in your mind, then at that moment the design procedure gets started. So that idea or the purpose for which you are going to design a machine is known as the need or aim. So first step is to identify the need or aim for which you are going to design a machine. Okay, so that is the procedure that can be done in your mind, and that can be thought using the creative ideas. Okay, so whenever you think about any design, any machine which will serve a purpose or which will serve your need, then that thought will create a first step in your mind. Okay, so the second step is the synthesis or the mechanism. A synthesis or a mechanism is the immediate second step after the first one. Why is so? Because whenever you think about a design machine which will serve your purpose, then you will also have to design about a mechanism that can make it possible. Let me give you an example. If you are thinking to pump a water from the ground level to the second floor, then you need to think about the mechanism that can pump up to the second floor height which can pump the water up to the second floor height. Now, what is that type of a design? What are the possible design for this purpose? A centrifugal pump is also possible. A reciprocating pump is also possible. So, a reciprocating and centrifugal are the mechanism, and from those mechanism you are going to select one, and based on your selected design you are going to design your components. So this is the second step, where you will select a mechanism to serve your purpose. Okay, so this is the second step. Now we consider the third step, that is the analysis of the forces. As you have selected the mechanism in the second step, now you will have to select, now you will have to analyze the forces that can be applied on your mechanism, and you will have to identify the maximum amount of the force, so that you can ensure that your components or your mechanism will work satisfactorily without any failure into the working conditions. Okay, so first of all, the analysis of the forces does not contains only the analysis of the forces, it also contains the analysis of the stresses as well as the analysis of the safety level. So in the third step, we are going to analyze the forces, stresses, safety level on paper. So on the first two steps are the steps that can be thought in your mind. The third step is on paper analysis, and the fourth step is the design of elements. Now you have selected your mechanism and analyzed the forces and stresses that can arise in your working condition. Now what you are going to do in the fourth step, you are going to select the design the elements according to that particular forces. You know the stress level, that maximum stress level that can go into the working condition, and based on that stress level you will be able to design the cross section area that can sustain that stress level, or the shape that can carry the forces that you are going to apply, the forces due to the working of the mechanism. So in the fourth step, design of element is carried out. If you want to have an example, then you can take an example of the reciprocating piston that is used in your pumping mechanism. Now you know that how much forces are going to be applied in your mechanism, and based on that you will select the cross section area of your piston, and connecting rod dimension can be calculated using that particular step number 3. So this is the step number 4, where you will design the different elements of the mechanism. After the completion of the step number 4, the step number 5 is the material selection. Now this is a very crucial important step in the design procedure, where the designers has to give their extra efforts to provide the better material or the optimum material for the or the best material for their design. Why so? Because whenever a designer is designing any machine component or any mechanism, then his purpose is to keep the mechanism very safe during any working conditions. So he will try to make the design robust, or he will try to make the design very rigid, so that it can sustain any forces that can arise into a working condition. But what happens sometimes, in order to create the robust or a rigid design or a very strong design, you will have to utilize a very good amount of a material, very good property of the material, and good property materials are very costly, and that's why the cost production department always try to reduce the cost, and that will impose the those production line will try to impose the allegation on the designers that you should cut the cost by changing the material. If any possible alternative available, then the cost could be reduced in order to reduce the cost and increase the sales. Okay, so these are the difficulties that the designer has to face, and the designer has to compromise between the cost and the properties of the material and select the best material that can fulfill both the material properties as well as the cost of the design. Okay, so this was a very difficult part of the design procedure. And the fifth step is the modification. as we have designed, as we have selected our material, based on the material property, we are going to modify our dimensions that we have already calculated in the step number 4 of design of elements. Because based on the material, the properties are going to be changing, as well as their strength, hardness, and different properties are going to be different for the different materials. And that's why you will need a modification in your dimension that you have already calculated in the step number 4. Now at the step number 7, we will draw a detailed drawing of each and every modified and the final components, so that we can provide that detailed diagram with each and every dimension to the production department. And as soon as you provide that detailed drawing to the production department, the final step of the design procedure is the production of that components and assemble those components in order to complete the design. So these are the 8 steps, and starting of the machine design happens at the moment where you think of any design components or a mechanism to fulfill the purpose, and this procedure ends after the completion of the production to create the mechanism or any components. So these are the design procedure that can be asked in your examination into 5 to 7 marks. And now we will see another theoretical portion, and this theoretical portion can be asked in your examination up to 2 to 3 marks. A question that is asked as what are the types of the loads? That identify the types of the load or enlist the types of the load. So there are basically different types of the load available, but the basic are the 3 types of the loads available in our syllabus. Those are, first one is the static load, second one is the fluctuating load, and the third one is the impact load. Now the static load name itself indicates that the load is static, and the load is nothing but the force. So the force need to have 2 different parameters to identify its magnitude and directions. So if the magnitude as well as its directions are steady, or with respect to time it is not changing, then we can say that your force or the load which is applied on the during the working condition is the static load. But if your magnitude or direction or any one of them is changing with respect to time, then we may have to say that your load is not steady, and that's why it is known as a fluctuating load. Now the fluctuating load and the static load are the opposite of each other, but impact load is something like different from those two, and impact load can be defined as the load that is suddenly applied with some height or a distance. So whenever you apply the load on the component or a mechanism with some height or any distance, then that type of a load is known as an impact, because it will try to create an impact on your component. Okay, so these are the basic types of the load. There are a lot of type of a load available as a subtopic of those 3, but we will see those detailed classification in the upcoming lectures. Now we will see another theoretical part, that is types of the stresses. What are the different types of the stresses that we are going to utilize in the procedure of the machine design? So the first stress is the tensile stress, and the second one is the compressive stress. Both are the stress based on their nature. So if you are applying the tensile load on the component or a compressive load on the component, that will create the tensile and the compressive stress respectively. Now the third one is the bending stress, which can be caused due to the bending of the member, or bending due to the application of the bending moment or a shear force. Okay, so these are the different causes of the bending stress. Fourth one is the direct shear stress, where you can find this direct shear stress where a force is applied parallel to the cross section area of the component, where you will find a zero angle between those two, and this will create the shearing of the component, and that's why a direct shear force or a direct shear stress will generate the highest deformation of the body in the skew manner. The fifth one is the torsional shear stress. Now the torsional shear stress are the one which causes the twisting of any component, or which causes the rotation of any component. So the torsional shear stress are the one which will be applied at some distance or some eccentricity, because due to the eccentricity the moment will be generated, and this moment will cause the twisting or a turning effect of the components. The sixth one is the bearing pressure. Now the bearing pressure and the crushing stress are almost the similar. The only difference between them is based on the relative motion of the two different components, that will be explained in the upcoming lecture. And the last one is the contact stress that you are going to learn in the upcoming lecture, that is the stresses generated due to the contact between the two curved surfaces. Okay, so these are the types of the stresses that you need to identify and learn in this particular syllabus. Now we will see another theoretical portion, that is the factor of safety. Now what is the factor of safety? In the design of the mechanical system or any components, always there are certain areas of uncertainty, and in order to ensure the safety of the system against such uncertainty, the factor of safety is used in the machine design. So again, it does not clarify what is the factor of safety actually is. So factor of safety, the term can be defined as the ratio of the material strength, that is also known as the ultimate strength or the yield strength or endurance strength, to the working or allowable stress. So mathematically, the factor of safety is nothing but the material strength upon working or the allowable design stress. So factor of safety for the static loading of the ductile material is where the yield point is clearly identified or defined. The factor of safety based on the yield strength can be defined as the yield strength upon working stress. And similarly, for the static loading of the brittle material, where the yield stress is not defined, you will continue this equation with the ultimate strength. We will not utilize the yield strength because it is not clearly identified or defined. The factors which are going to be important for the selection of the factor of safety are the degree of uncertainty about the loading. If you don't know what types of the loading are going to be applied on your component or a mechanism, then you will have to provide the better factor of safety. Degree of uncertainty about the material strength. So if you are not certain about the material, or your material strength or its property is not reliable, then you will have to provide the better factor of safety. Uncertainties in relating the applied load to material strength, consequences of failure, human safety and economics. So if you are designing a machine which can cause the human life threats or the economical threats surrounding it, so then you will have to provide the better factor of safety irrespective of the cost. Cost of providing a large factor of safety. So whenever you are providing the large factor of safety, the cost of the machine will definitely be increasing, and if it is worthy, then it's okay, but if it is not, or if it is increasing the cost factor unnecessarily, then you will have to reduce the factor of safety in order to cut the price. Now we will see another example based on the factor of safety, which is a very simple example. A rectangular bar of 40 by 60 mm size is subjected to a tensile load of 100 kilonewton. Select a suitable material from below it. So we have two materials. First one is the mild steel, that is having the permissible tensile strength of 90 megapascal, and second one is the cast iron with the permissible tensile stress of the 20 megapascal. Now we will see that the maximum tensile stress based on the working condition is how much. So we will calculate the maximum tensile stress based on the working condition from the equation force upon area. So force is F upon B into D. So force F equals to 100 into 10 raised to 3 divided by 40 into 60. So if you calculate using the calculator, you will get the tensile stress as 41.66 Newton per mm square. Now compare this 41 Newton per mm square with the permissible tensile stresses of the materials. As you can see, if 41 is greater than the 20 megapascal, which is the maximum permissible tensile stress of the cast iron, and that's why the 41 Newton per mm square tensile stress will fail the cast iron material. So we cannot select the cast iron, or the cast iron material is not suitable for our design. But as you can see, the 41.66 is less than 90 megapascal, and that's why the mild steel can definitely sustain this much amount of a stress without any failure, and that's why the mild steel material is suitable for our design. After the completion of example, we will see the last theory of this chapter is a lecture, that is the stress concentration. It is also asked in your examination sometimes with the 5 to 7 marks. Based on the marks, you will have to explain these theoretical points. First one is the definition of the stress concentration. What is stress concentration? Whenever a machine component changes its shapes of cross section, the simple stress distribution is no longer holding very good, and the neighborhood of the discontinuity is different, and this irregularity in the stress distribution caused by the abrupt change of the form is known as a stress concentration. As you can see in this diagram, the material is changing its cross section dimension at this particular level. At this level, its cross section is getting changed, and it is reduced to this much amount of the dimension. Okay, so previously its cross section area was this much, and now this cross section area is reduced. So as this area is getting reduced, or it is reduced from large to slower, you can identify the irregularities in the stress distribution lines. These are the lines which indicates the stress distribution into the material. As you can see, these are the irregularities, and maximum irregularities is here, where you do not find the equal amount of spacing like this or like this. So the spacing over here is the same equal, as well as over here is the equal, but the spacing over here is irregular, as well as the spacing is somewhat dense as compared to the different part of the component. So whenever the line spacing of the stress distribution line is irregular as well as dense, then you can say that the material is having the stress concentration at this particular point. And due to the stress concentration, this region is the weakest portion of the component, from which your component is going to fail if the loading is increased beyond the certain level. Okay, so we will see the method of reducing the stress concentration and how to avoid the stress concentration. So if you are designing any component which is increasing its cross section area from lower to higher cross section, and if it is subjected to a bending moment like this, then you can provide the notches or the slots over here. So these slots will reduce the effect of the sudden changes into the cross section area, and the notches can be provided at the sudden change over here also. So these are the different methods. This one is the poor method, and we do not prefer this method, but this one is good one, and this one is the preferred one. We should prefer this method. Okay, so these are the different methods of reducing the stress concentration. Similarly, if you are designing a component which contains the thread, then the thread should not start its thread. We should not start our thread suddenly from the components. We should provide us a gradual change into the thread, so that the cross section should be gradually change. The cross section gets gradual change into it, and which will reduce the stress concentration into the component. Otherwise, we can just provide this much amount of a direct cross section, and after that thread should be made, which will reduce the stress concentration into the material. And if you are designing a component which contains the hole in the middle of the component, then the hole will suddenly reduce the cross section area at the spot. And if you want to reduce the stress concentration, then you can provide two different holes over here and beside the major hole, and this small hole will reduce the cross section area gradually, and that's why the stress concentration in the material will be reduced. But this method is not applicable in each and every cases, because by providing the through hole, the strength of the material will be always reduced, and that's why we do not recommend this kind of a method in each and every case. Whenever the material can sustain the stresses up to the certain limit, then you can apply this third method to reduce the stress concentration. So these are the points which I have discussed regarding the design against the static load. Now we will see a few more topics and the application based on those concepts in the upcoming lecture, and we conclude our lecture over here. Thank you.